Quantitative electrolysis. First question. If a quantity of electricity is passed through a molten sample of aluminum chloride, it is found that 0.2 moles of chlorine are formed. What is the mass of aluminum formed at the other electrode? So molten aluminum chloride consists of dissociated aluminum ion and chloride anion. Ions, so aluminum chloride, aluminum plus 3 plus chloride negative. Ions present, aluminum and chloride. Reduction at cathode, aluminum plus 3 electron give aluminum metal. Oxidation at anode, so chloride will give chlorine plus electrons. So if 0.2 mole of chlorine is formed at the cathode, then this can be used to determine the total amount of electrons released in the oxidation of chloride at the anode. So number of moles of electrons equal 2 times number of mole of chlorine equal 2 times 0.2 mole equals 0.4 mole. Number of electrons released in the oxidation at the anode must equal the number of electrons accepted in the reduction at the cathode. We can use this to determine the number of moles of aluminum metal discharged at the cathode. So number of moles of aluminum equal number of moles of electrons divided by 3 equals 0.4 mole divided by 3 equals 0.13 mole. Also, you can calculate the number of moles of aluminum formed by using half equations and overall equation. So it will give you the same answer. So mass of aluminum equal number of moles times molar mass of aluminum equals 0.13 mole times 26.98 gram per mole of aluminum metal equal 3.5 gram. So here we put the answer in two significant figures, but in the given data it was only in one significant figure. This is why if we round up the answer, there will be a big difference between 3 gram and 3.5 grams. So this is why we use two significant figures. Next. Which of the following will cause the largest amount of copper to be deposited during electrolysis? So the answer is C. As this is a multiple choice question, it is necessary to be able to deduce the answer without determining the exact amount of copper that will be formed in each electrolysis. The answer can be determined by calculating the total charge involved in each process and then how many electrons are involved in each reduction. So copper plus 1 requires 1 mole of electrons per mole of copper. Copper plus 2 requires 2 moles of electrons per mole of copper. Charge equal current times time, and time must be in seconds. So here charge equal 5 ampere times 10 times 60 to convert it into seconds, the minute into second equal 3000 C for a 1 electron reduction. And the same but for 2 electron reduction. And then if we use 2 ampere times 30 times 60 seconds, 3600 for 1 electron, and the same amount for 2 electrons. So of course 3600 is higher than 3600 if it's for 1 electron compared with 2 electrons. So the answer should be C. A metal spoon is plated with silver using an aqueous solution of silver nitrate and an impure silver anode. Predict how the mass of the 2 electrodes will change with time and what other changes might be visible. For plating any metal, it must be at the cathode during the electrolysis. So in electroplating, the metal is deposited at the cathode as the anode decomposes, or while the anode decomposes. Reduction at cathode, silver cation plus electron gives silver metal. Oxidation at anode, silver metal gives silver cation plus electron. The mass of the silver anode will decrease as silver is oxidized to silver cation that are released into the solution. The mass of the spoon, which is at the cathode, or this is the cathode itself, will increase as a layer of silver is deposited on the surface. The metal surface of the spoon will become shiny gray as the layer of silver metal is deposited. Impurities may be visible collecting as a sludge at the bottom of the electrolyte solution as they fall from the decomposing impure silver anode.